Are you explaining every program or only yours?
No, all programs.
Okay. Have you finished fifth one right now?
No, I'm starting with the fourth one. I'll restart again freshly. I'm starting with the fourth one, and I'll go in any order you request. Okay.
Okay, okay, thank you.
Mm. So fourth one is a lexical analyzer with given assumptions. So the input for this program is a text file like this one. Ideally, it should be a code, but need not be a code only because we're not checking any semantics. We'll just pass the given text file into known tokens and store it in a output file like this with each token and what we recognized it as. Not even attributes assigned to it, just a token. If you don't identify it, if it the particular token is not classified, we don't write anything beside it. Okay, so coming to program, Excel program. I'm writing this program in the software ma'am wrote edit ma'am shared in week 3 PDF. It's a Lex and Yak editor, but we have to execute to compile it and run it. I am using a command prompt, though we can run it in this also. I prefer command prompt. At first, we have to set the path, which we already did. Okay, to start with the program, the first line in all my lexical programs and Yak programs is option percentile option no YY. This is optional. See in the MAMS programs, you will find another function below main function which says uh, int yyRap returns 0. It's like a formality function that is used to combine multiple Lex programs. Uh, we don't need that. So yeah, I will show how to compile everything after explanation. We'll go through it. I'll spend some half an hour, 1 hour in this. Okay. So since we are not going to use any in any of our programs that option YYRAP. So in all my Lex programs, I'll include percentile option YYRAP. Now the Lex program contains four different segments. The first segment is percentile brace. Inside this, all the C variable declarations. Second segment between double percentile and double percentile is the lexical grammar, recognition, and beside it is again a C code. Here, this is like a regular expression, and beside it a C code. What to happen if it encounters that? And the third part is like for the functions, and anywhere in between them, like in the global space of C program, you can declare lexical variables. Just to put all in one place, I declared all the lexical variables in at the top. So in lexical variables, I declared regular expressions names like a digit and a regular expression for digit, ID, decimal number that is float, and a float number in exponential form, and few 10 keywords. Well, the question asks to identify 10 keywords. Uh, identifiers go with the variable, the naming convention, right? Any string which follows the naming convention, signed and unsigned integers, floats in both the formats, these relational operators, the assignment operator, and single line and double multi-line comment. And whenever we encounter a new identifier, we have to store it in the symbol table. These regular expressions, I'll go quickly. A digit, anything between square bracket is must choose one. It will choose one character among the given list. Only so one among plus or minus. Question mark makes it optional. That is 0 or 1 time. 0 to so in square bracket 0 to 9. That is any one character between them. Plus the difference between star and plus is star is 0 to n times. Plus is 1 to n times. So one character among plus or minus optional, and at least one character of between 0 to 9, because a digit must have at least one digit and can have any number of digits. Next in identifier, a small character or a capital character or underscore once, mandatorily once, just and from the second time onwards, it can have any number of times. We didn't directly use a plus here, like we wrote this and plus, because the first character cannot contain digit. A variable name cannot start with a digit. So that's why the first time it's a separate rule, we wrote separately from second to n times a star. Next, for a decimal float value, till here is a digit, an optional dot, that is the decimal point, and after decimal again any number of times. But if a dot is there, right to it, at least one digit has to be there. Whereas on the left side of it, any digit need not be there also. Like for example, a 0.5 is a valid. We assume that the left side is 0, but we don't have to care about that. That's the job of semantic analyzers, the further parts. Right now we just have to identify a 0.5 also as a separate token. And with sign, a minus 0.5, 0 is optional. But minus 2.5 is also should be accepted. And exponent is, we already defined a digit, so we can use that, a digit and a mandatory E and a digit. And the keyword, the any 10 keywords, each keyword is a string, and this is R. Okay, these are the lexical variables. And in C variables, so you have to include the header file string.h. See, stdio.h is by default included, so no need to include write this just to include stdio.h. It's by default included in all Let's programs. If you want any other header files only, then you have to include it. So string.h and symbol declare the 2D array, character array for symbol table. Symbol table stores the different new identifiers which we recognize. So each identifier can be of 30 characters and a table of 20. So 20 strings. This table is for 20 strings. And a function to store an identifier into a string table. Now coming to main, these were variable declarations. I'm going just in the order of flow, how a compiler, while executing, how it will read it. Declare the variables. Next, jump to main function. In main function, we are giving our input as command line input. Command line input means while executing itself, beside the execution command, you give the inputs also. I didn't follow the general naming convention to name these variables. In anywhere in int and max, they use another thing. Like in Java main function, you must use arg, right? It's like a unofficial tradition, but I broke that and used s. A says the number of inputs, number of command line inputs, and s is a string for all the inputs. You have to again parse it and do something. Okay, yeah. So here is the input I gave a text file. The input I'm giving in command line input is the name of the text file. So currently in.txt is stored in s. I'll store that file name in yyn. Yyn is some inbuilt lexical analyzer variable which says that read the input from there. So fopen is a C file handling things. Fopen s of 1. This entire thing is like s of 1. S of 0 contains some other inbuilt thing like the number of variables, I guess. And open the file in read mode and write the output to out.txt. I don't want the output to command prompt. Right, open that file in write mode. In main function, these things are only for the command line because we are giving command line input. If it's a normal program, also every main function must contain yylex. This yylex will jump to here to the double percentile portion and it will start doing its job, that is lexical analyzing. So we encountered yylex. Right now till now we declare the variables and open the both files. Now we jump to the double percentile. So first to identify these things, it's like an if-else ladder. First it will check this. If it fails, only then it will go to this. Else if like that, and the last one is else. Okay, so the order of these are written is also like important. Order is important. So first foremost we have to check for multi-line comment, because inside a multi-line comment, even if you have whatever any of this, it shouldn't matter. So the most important thing we first check is for a multi-line comment. Now this is a regular expression for multi-line comment. Don't try to understand it in depth. Just take it that this is a regular expression to identify multi-line comment. I can tell you just briefly. It should contain a start with a /* and it can contain any number of stars or it can contain a slash star, but a closing should be a star and slash. This cap symbol in a regular expressions means start of a line. If it contains multiple star slash, again all of them it should not contain, etc etc. So many things are there. Plus star plus, it can have star and the last at end it should again close with slash. See here, just note this, at the end it should have a star and a slash. Difference between we everywhere we used fprintf. Fprintf is to write to a file. Printf will print to the command to the terminal. Fprintf will print to a file. For fprintf, you must also give a first argument, the file name. Here the file name we are giving is to YY_out. So everywhere fprintf YY_out, and whatever you say will be printed. Instead of printing it to the terminal, it will be written in the out.txt. Okay, so if it accepts this, then it's a multi-line comment. I'm printing multi-line comment, a new line. So in my input.txt here, I have a multi-line comment after -5 plus c. So after -5 plus 9, here I have a multi-line comment. You don't have to print the content of the multi-line comment. Just say that it's a multi-line. There's a multi-line comment. Oh, here I explained the regular expression. I didn't see. Okay. Next, identify single line comment. Any line starting with a double slash and only till one's line. The second line till it encounters a new line. When it encounters a new line, again close the commenting. Next, any of the keywords, these particular relational operators, print them as LE, less than or equal to. LT is just less than. GE is greater than equal to. GT is greater than. Equal to, not equal to. What we're doing is, for all of these, we are printing it as, see, look at the output format. We want to print the token identified, colon space, the token name. So to show what token is identified, %s, it's stored in YY text. YY text contains all the characters accumulated till now. So like when it starts, it's parsing, it will start here. If it encounters a space, it will pass. We know that, how it will understand later. So till here, it keeps accumulating in the YY text. Whenever we print it somewhere, again it will clear it, and again next it will start accumulating in the YY text. Okay, so we are printing that YY text and what is identified. Assignment operator, and similarly exponent. The regular expressions we already defined them. These for them. Actually, you need not declare them as variable. You could have even written the regular expression, these things directly here. But just for clear clarity, we declared it separately and then used it here. Because if you use the expressions here, you don't know which. Because the order of these are also important. First, you must identify an exponential, then a decimal, then an integer, then an identifier. Okay. So lastly, but we are more interested, we have to do more work with the identifier. See, if it's a keyword, then it's identified first only. I mean, that's after comments. If none of these match, then it's an identifier. If it's an identifier, means already accepting, following the naming conventions. Then we'll print it and immediately call this function, store symbol table function. So let's jump to the store symbol table function. Before jumping that, let's finish this also. If it's encounters a space on new line, do nothing. We're not printing, you don't need to print it. Because already in the out.txt, we're printing slash and everywhere here. So you don't need to print these again. And any unknown, unspecified, unclassified character. See, we didn't write the entire lexical program, just for a few things. So for any other dot, print the dot as it is. So in case, say for example, a parenthesis, we just printed. It means that it's written in the program, but we didn't classify it. Okay. Now, whenever we identify the ID, we jump to another function. We call a function store symbol table. It's taking an ID. It's taking taking a string which is YY text. So what it will do is, by the way, recall symbol table is a 2D array which we declared. 2D array for 2D character array because it stores strings. These are for 20 strings, each string of 30 characters max. So in the symbol table, what we should do is first whenever you get an ID, you check if the identifier is already in the symbol table. So this for loop checks if that symbol it will run a while loop, for loop on all the available strings. That string compare the symbol table of I and yeah. So actually I must have, when you declare it, I think it has initialized all the values to empty strings. So till it's not an empty string, this checks that for all non-empty strings in the symbol table, and I is less than 20 because we declared the size till only 20. This 20 you can change. If none of the strings match, sorry, if it is match, if your identifier is already in that symbol table, then simply return. It's already there. You have to do nothing. If the for loop completed, meaning it's not a match, and it didn't break because of I less than 20. That is, it's not an overflow of symbol table. If it's overflow, also then return. This is like option, because of our programming. If we created a linked list instead of a 2D array, then this would not have been there. Okay, you can ignore this for now. So in this for loop, if you didn't find the identifier in the symbol table already, then you have to store it. That is symbol table I is already at the last row. Symbol table string copy. We are dealing with strings, so you can't just assign. You have to use the function string copy. For the string copy only, we included string.h. Copy the identifier at symbol table of I. Okay, and that's it. That is the entire program. So how to run it? In GitHub, in CD, in command prompt, open the link first of all. Any flex program, flex. I think my file name is lexanalyzer.l. It will create a lex.yy.c video. GCC lex.yy.c. It created a a.out somewhere here, a.application, a.exe. So actually, if we just run a, if we were giving input as normal input, then we would have run it as, then we would just run a and give the input in the next line. But for command line input, you give the input beside the input here. So in.txt. No output is printed here. It's processing. It's still processing. You don't have to enter anything. It will generate the out.txt. Nothing will be printed here. Okay. It's still taking some time. Okay. So you can open out.txt and check. These are the new identifiers it recognized. 3 identifiers it recognized. That's it. That's table 4. That's program 4. Any doubts? Ashta Saiti.
అది లెక్స్ ఇందాక ఏది ఒకసారి కమాండ్ ప్రాంప్ట్ ఓపెన్ చేయవా? lex.yy.c అదేంటి?
These are the commands. First, you must execute flex.
కిందది GCCది.
See, when you run flex.filename.l, it will convert the lex program into a C program. Next, the C program's name is lex.5y.c. It's standard for any program, not just for this. GCC is just to run the C
GCC,
program.
okay.
You see that C run that C program. See this lexical analyzer just Lex just converts your code into C.
C.
Yeah. Then next you have to run that C program. When you send that, it'll create a object to code like a.exe. You run that a.exe and you give the input.
Okay. Thank you, Sriram.
Thank
Okay.
you.
Next, fifth question. Oh, fifth is not there. We didn't do fifth. Oh, what's the fifth in your question? I have to check. Predictive parser using C. Which one is that?
Week 7, lab 2.
What? Repeat.
Week 7, second program.
Okay, it's a C program.
C program.
Okay, a non-recursive decent parser, predictive parser for the given grammar. So you must give some input grammar. Say D plus T star T.
ఇది రికార్డ్ చేయగలవా?
Yeah, I'm recording the entire video.
ఓకే. తర్వాత
I'll put it in my YouTube.
ఓకే.
Okay. So what we should do here is what predictive parser does is you must identify the grammar symbols which we have to. Because actually, if you write it manually in the notebook, you write it as a table, but here we are printing all the just action parts in line. So first, let's understand the output. It's like a parse. You must generate the parse tree. I don't want to annotate because I don't have pad. I don't want to write. So let's say you start at E. Okay, I'll try to annotate. E. You start with E. So first it's saying that go to TE dash. Next this T goes to FT dash. And this F goes to D. Whenever you get a terminal, you make a match of D. Next this T dash goes to epsilon. Next this E dash goes to it goes in a left associativity. This E dash is going to plus TE dash, like you got the idea, right? So if you follow these things, it's reading the commands you should perform in the tree in a left associativity. So basically you are generating a tree and printing it in the command steps in linearly. Okay, you're generating a parse tree. I'll clear this 1 second. Now let's understand the program. And after generating the tree, it'll at the end of the program, you'll know whether the input string you entered is either parsable or not. You know, all strings, whether if it's accepted by this grammar, only then you'll get a proper parse tree. If it's not accepted by this grammar, if it doesn't belong to this grammar, then you'll not have a tree only, then you'll get just an error message. The program is very easy. To execute this, you need a stack and an input pointer. Input to store your input string and a stack. You utilize the stack. Let's understand why. And since there is stack, you must have a push pop functions. That is just to deal with the stack. Whenever you call push, it will push in the stack, and when you call pop, it will pop from the stack. The error function will just display the error at the end of the program. Let's go to the main function. At the starting, for declaration, you display the grammar and ask to enter the string, and you are pointing the pointer IP to the when you say IP, it will be pointing to the string. If you increment the pointer IP, will be pointing to the first character of the string. If you say IP++, it will point to the second character, and you can no longer access the first character, and from that character to the entire string. If I say IP+2, IP is here, and if you say print IP with %s, it will print only the rest of the string, and the first characters will be gone. And is this length of the string? You can understand all this. It's better if you understand know the predictive parser theory. Okay, but right now I'll just explain the program, which you have to do in the video. And append at the end of the input character. Input, append a dollar to your input, append a dollar at the end. Okay, that's what we did here. And then make the next character as a string. Otherwise, it will be just a character array. To make it a string, at the end you must have a null character, right? Initially, when you take input, there will be a null character, but since you're changing the nth character from null to dollar, you have to make that next character to null. And the stack initially contains $E. So what are initial values? Stack contains dollar and starting symbol, and your IP contains the entire input and a dollar. Okay, now in a while loop, till the input is not completed. Stack contains $E. Input buffer contains the entire input, say W, and dollar. You run the while loop till either you get an error or this entire thing is processed. Each time the stack will be changing till only dollar is left in the your input buffer. Okay, if for the start only we wrote the breaking statement. We wrote a int main. So if I write a return command in int main, it's like the end of the program. It's like terminate the program. If the input character is 0, input of I. What is I? I is we initially declare I equal to 0 and top equal to 0. So right now I is pointing to the first character of the input. And later at the end of the file, we will somewhere update I also. Whenever you move across the input. If the current character IP is pointing in the input is dollar, that means your input is processed. And the stack doesn't contain any other thing except dollar. Except stack contains only one non-terminal. Stack of top should point to E. Stack of top -1 should point to dollar. Now the starting variable can be anything, that's why we didn't specify stack of top E, stack of top -1 is dollar. If these both are dollar, then you have successfully completed the entire thing. You print and you end the program. This is like the breakpoint we wrote of the while loop. We wrote at the first. Else if the current input pointer is a non-terminal, and even the stack contains both terminals and non-terminals. Okay, if the both are same non-terminals, the input will contain only non-terminals only. The non-terminals means the letters, in this only D. if this is T and stack also contains D, then it's a match of that character. You print that character and you remove the D from both of these. So I plus will remove the input, the character from input, and pop will remove it from the stack. Okay. If the top of stack is E, and top of stack is E, and the current input can only be D or open bracket. If it's D or open bracket, then print E becomes TE dash. How did you get D or open bracket here? That is the first of E. So for each of these non-terminals, you must calculate first. So first of E will be first of T. First of T will be first of F. First of F is open parenthesis and D. So first of E is also parenthesis and D. Since nowhere there are epsilons, that's it. So in stack of E, and the input characters are the first of E, which are D and open, then this. If it's not if it's some other non-terminal, that is, say if it's a closing bracket also, then also it's not, you don't go into this. If these two match, here it's an OR, here it's an AND, then it's then it's E becomes T dash. You print that. Now, after you if it's a match for E becomes T dash, what you do is you must pop once and push A and T. Why? Where did okay, here the wave non-terminal E dash, actually we must push E dash and T, but E dash will become like two characters. We can't deal with, we are dealing with only single characters. So I renamed E dash as A. Wherever you see A, think of it as E dash. Understood this point? E dash is two characters, but we are dealing with only, see, here stack of top minus 1 equal to E. We are just taking one character. If it was E dash, you cannot use equal to. It will become a string. Okay. So wherever E dash, replace it with A in the program. In output, you can display whatever you like. In output, you will display E dash, so the user will not know. Only you will and the compiler will know. So what you should do, it's not bottom-up parsing. You're going in order, right? So if you encounter E, you must replace it with TE dash. So you pop E, you pop this E from the stack and push TE dash in reverse order. So first you push E dash and then push T. Okay. First you push T dash, because what will be evaluated next? What will be the top of the stack next? T should be at the top. After E, as per left associativity, you must execute T next. If you want T next, if T should be on top, then E dash should be pushed first. Got that right? Okay. So this logic you have to explain. You have to apply for all your grammar statements. So for E becomes T dash, stack contains C and first of E is this. Next, if stack is E dash, if stack contains E dash, and the first of E dash must be plus, because here itself is a plus, or epsilon, it contains epsilon also. So first of T is also included. What is first of T? First of T is F. Okay, actually I think this is wrong then. Oh no, sorry. E dash becomes F, E dash becomes epsilon. I must have written it somewhere separately, or this program is wrong. Let's see. Let's go through it and find out. Okay. Then E dash becomes plus T dash. For this you pop once LHS and push E dash, T and plus in reverse order. Same if it's A becomes, what is A? A is E dash, right? If E dash becomes epsilon, okay, we wrote it separately, that's why we didn't include the first as here. These two, though we are here, we printed it as one. These are, you treat them as two separate productions. So for A becomes epsilon, that is E dash becomes epsilon. The first of this will be closing parenthesis and dollar. Dollar is the last symbol of input, right? So even that should be included in first while calculating first. Here, when E dash becomes epsilon, you just pop E dash, but you don't have to push anything. You don't have to push an epsilon. Okay. And for other productions also, T becomes for this T, first of T must be D and open. You pop T and push open, and you push T dash and F. Even T dash, I renamed it as B, same reason. So wherever you see B, think of it as read it as T dash. And you do for this production and this production and this production and this production. These are all same. Let's check for F. When you encounter F, okay, I wrote when you encounter F and the input contains D, you print F becomes D, you pop F and push D. And when you encounter F becomes open ED, just first of this, first of F only contains, this part contains only open parenthesis. You pop F, push in reverse order. You first push, you're pushing in reverse order. If it doesn't match any of the non-terminals, that is in case there's a new non-terminal which is not in your grammar, also then an error. This runs in an infinite while loop. So every time in every condition, in every iteration, you're changing the values of stack, right? So the top of the stack will always be changing, and even whenever you get a match, the input character will be changing. So in different value, you will get different things. Either the entire input character gets processed and stack becomes almost empty, then it's a successful. Or if you either get a mismatch or anything, in the table there are many errors if you know the theory, then it's an error. And what is error? Error is not an inbuilt thing. You defined a function named error. Error function, what does error function do? You print that syntax error, string is invalid, and you exit. Now, what are the valid strings for this expression? Is any arithmetic expression which contains the operator star, multiplication, addition, and parenthesis. If you use a division here, it's again an unknown operator. So any valid arithmetic expression is accepted by this grammar, and any valid arithmetic expression is not accepted. Let's look at this. Syntax error. Okay, that's it.
Sir, can you please send this code?
It's in my GitHub.
Okay.
Week 7 program 2. Okay, next. What program do you want next? Okay, 3. Third one, recursive descent parser. Any idea which program is that in the week, as per this?
Sir, delete. No.
Recursive descent parser. Using C. Hit.
వచ్చిందా
This week
ఓకే
6.
యా ఒక్క నిమిషం హర్ష వస్తుండు వాడిది కూడా ఇదే
రికార్డ్ చేస్తున్నాను కదా చూసుకుంటాడు
ఓకే డన్
Okay, say the question is same as the previous question. That is, build a parse tree for the given grammar. Just the method, the type, how you build a parse tree is different. Earlier we built a different type of parse tree. Earlier we built a recursive descent parser.
No.
No, earlier we built a predictive parser. Now we are building recursive descent parser. But both are parsers only. In both the cases, you are building a parse tree, and you're building that tree in left to right thing. Okay. So initially, even this much, the difference is that it doesn't have a stack. In this, you're calling it with functions. There, you maintain a stack and an input buffer. Here, you only maintain an input buffer, and the rest is just the way you call the programs. Another difference is that in that predictive parser, it's like a generalized program. You can use that program by just changing the grammar, because the table, when you change the grammar, it has like the theory concept has a table. Whereas here, it doesn't have any table or anything. Yeah, the entire program, the way you call functions change. So in this program, your video explanation, you start by explaining what is recursive, what type of parser is recursive descent parser. It's a top-down parser. You can even annotate and draw the tree for any one input. Valid inputs are any arithmetic expression with a plus and star and parentheses. Okay. By the way, you cannot write type epsilon. So in place of epsilon, I think ma'am used the symbol cap. This is epsilon. Okay. Fine. So the program is for this program, for each non-terminal, you create a function. So the non-terminals you have are e dash t, t dash f. Since it's a function name, you can write it as however you like. For each non-terminal, you create a function and input pointer and input string. So the input will be stored in the string. Pointer just points to the current character in that string, the current character in the string. You input the string. These are just for decoration to print like this. Well, and in the main function, you first call the starting variable, starting non-terminal. The starting symbol is e. You start with e. Where did you call it? Okay, you're calling e here. Now each of these non-terminal functions will either return a true or false. So when you call this e, if it returns true, that is, the e will recursively call different functions, and if all of them return true to each other, and finally if e returns true, and when it comes back to the main function after all the thing, it is you're at the end of the program. At the end of the program, if your input pointer is pointing to the end of the string, that is null, then it's a successful parse. If either, it's an AND. If either e didn't return true after doing all that, what we are going to see, or if after e is completely finished, the input is not pointing to the end of all the input is not processed, then it's an error in parsing.
It's equal to 0, then it's called recursive.
No. Recursive means in this function e, you will be calling some other function. From inside this function e, you will call another t. In that t, you will call another e dash. So you will call you initially from the main function, you call only e, and from the t, you will call all the other functions. Okay. Yeah. So right now you called e. Before you even go there, first it will call e, and after completing the entire trip, it will come, only then it will check this. So first when you call e, when you come here for the first time, so right now your input is still pointing to at the beginning of the input string. So your IP is pointing to the first character. So IP is here, and the entire input string is still there. You call e. You first print the first production by default. So in the action, this line will always be built, even if it's a successful pass or an error pass. The entire input will be printed, and the first starting variable's production will be printed. Now the production says e becomes te dash. So you call t function and e function. So you first call t, okay, and within that t you call e dash. If this e dash In this E dash, there's no, there's no terminal. So if the E dash is true, you return 1. Where do you return 1? This return works for E. If you understand one program, you will understand all the. If you understand one function, all functions are same. In E becomes TE dash. So first you check for T. If T is true, then return. And if T is true, then you check for E dash. If T itself is false, then directly return 0. 0 for E. The function E will return 0, false. 1 means true, 0 is false, okay? If T is false, return false. If T is true, then check for E dash. If T is true, job is not done. Check for the second function. If second function is also true, then return true. If first is true and second is false, then also return false. Got that? It's like an AND. Both should be true, then only you return true. That is here. If either of them are false, then return false. Now what does this T function do? Again, the T will do same logic for T's production. What is T? T's production is T becomes FT dash. So without seeing the code written there, I can tell you the code from here now. The T function, it will return int T. It should return a 0 or 1. Int T. In that, it will first, if you have reached that function, you can print it. You can print the current input, whatever is left, and you can print T becomes FT dash. Okay. Then we'll check if F is true or not. Mean you true or not when you call the function F. If inside if you call F. If F, then you check if T dash. If both are true, then return 1. Else, where is this else? Inside F and below T dash. If F is true and T dash is false, then return 0. If F itself is false, then also return 0. Understood? Where is function T? Here is T. Understood? So same for all the functions. For all this E dash T, T dash F, all go in the same way. If a function has 2 productions, let's check for T dash. T dash has 2 possibilities, either star FT dash or epsilon. Or where's T dash now? If it's T dash, okay, T dash is different. Okay, before going to 2 productions, let's check if it has a terminal. If it has a terminal, if the current first thing is terminal, then you check the input also. Say for E dash becomes plus TE dash if it's a plus. And if it, then you'll first of all print E dash becomes T dash. This story you know. And if whenever you if it's you encounter a terminal, you increment the move ahead the input pointer, current input rest of the pointer that is processed. And if the current first symbol is false, then return 0. If first symbol is true, check the second symbol. If second symbol is false, return 0. If first and second symbols are true, check the third symbol. If third symbol is also true, return true. Else if first, second or third is false, then also return false. Got it? When you do all this, see, ultimately in each function you're returning either true or false, right? So in E, from E, you call T and E dash, you're calling 2 functions. If both of them return true, based on this pattern, the E will return something. So means E dash will call something else, T will call something else, and they'll again return back, and it comes back. And finally, when E will also return back to again main. So like that, ultimately, if E returns true and input is entirely processed, then it's a successful. Got it? See here, I skipped you all the functions. In your video, you simply read each production. You don't say similarly for all the rest of the functions. You explain each and every function in the code You just simply read t becomes ft dash. So this and this and that. Like that you explain for each and every function. That's it. Any doubts?
No.
Good. Next. Is that enough? I'll wait for 1 minute. Okay then.
Hello.
Okay. Yeah.
In my video, I can just like I'll say whatever you said and explaining everything, right? Positive అంటే ఈ పాయింట్స్ ఉన్నాయి కదా, ఇది ఈ కోడ్ లో ఒకసారి కిందికి వెళ్ళావా కొంచెం? ఇవి వచ్చినప్పుడు ఈ డాష్ 1 వచ్చినప్పుడు ఫస్ట్ థింగ్ ఈ పాజిటివ్ ఉంటే నెక్స్ట్ టర్మ్ అంటే ట్రూ అయితే నెక్స్ట్ టర్మ్ చెక్ చేస్తా, అప్పుడు రిటర్న్ 1 ఉంటది. నెక్స్ట్ కూడా పాజిటివ్ అయితే రిటర్న్ 1 ఉంటది, అలా నెక్స్ట్ కూడా పాజిటివ్ అంటే రిటర్న్ 1 ఉంటది. ఎల్స్ స్టేట్మెంట్ ఎప్పుడు వస్తుంది అంటే ఫాల్స్ అయినప్పుడే ఎల్స్ స్టేట్మెంట్ కి వస్తుంది. అదే చెప్పాల్సింది నేను. అదే అది కన్ఫ్యూజ్ అయినా కొంచెం, అంతే. అదే కాదు అంతే.
Okay. I skipped it. I forgot to come back. When if there are two productions, let's see here, e dash becomes either this or this. How do you say whether this decide between these two is? If the first character is plus, then you check this. If it is plus, then you next check for the t and e dash. If the first character is not f in the function e dash, it may also be epsilon. So in e dash, if it is not plus, you don't directly return 0. You check for it may be epsilon. The good thing about epsilon is you need not check for anything. Directly return 1. Epsilon production means just return 1. It doesn't need to satisfy any condition. Okay. If in case C for f, let's look at f function f. In f, if the first character is parenthesis, then it's the first production and you check for the e and e dash. You check for e and closing parenthesis and closing parenthesis within e. If the first input is not opening parenthesis, you don't directly return 0. You check for the second production. The second production is if it's an I, that is the identifier, terminal I, this one. If it is that, then then it's the second production. In second production, there's no second argument, like there's no second thing, there's only one thing. So if it's a match, that's it. And since it's a terminal, you increment the input pointer ahead and you return 1. If it's neither of them, that is, if you're in function f and the first character is neither opening terminal, opening parenthesis or input I, then you return 0. Okay, I just forgot to say that. So I think that's enough. I'll end the meeting now. I'll upload this video in YouTube. Okay, bye.
Hello, Sarah. Did you do the 6th one?
I think I did 3rd, 4th, 5th.
Okay. You're not doing the 6th one?
You want 6th one?
Yeah.
You should have asked. Okay.
You started 3, so I went to went some. This is the lab 8 first program.
Shift reduce pass, this one manually, there's man's video.
Yeah, I saw that. Just execute this once and just show me the right input. I didn't understand the right. Everything it says invalid if I execute it.
Using C.
It's the lab 8 first program.
Any arithmetic expression.
See?
Oh. Oh, there's an error, I guess. So,
ఒకసారి చాట్ చూడవా?
చూసా.
సేమ్ నీదే అది.
I want to figure out freshly. I think I understood. Wait. Yeah, got there, understood there. I shouldn't have closed that. We didn't append a $2 at the end of the input.
What?
And either it MAM's program. Wait a second. In the program MAM uploaded in okay. What we have to do is
In the input, it says your input should be followed by a dollar. I think you should add that.
oh yeah, that's it. Okay, so no need to, we don't have to append. I didn't enter a dollar at the end of. Yeah, that's it. We were ending the input wrong. What I was going to do was I was going to append the dollar manually, like by default, instead of us forgetting, I was going to append the dollar to the input here, automatically, so that we didn't. But the input you in the output statement you asked to enter. Okay, fine. Okay, got it.
Okay.
Yeah, so there's nothing wrong here.
Okay, fine.
Okay.
Yeah.
I'm ending the meeting.